Hi, I'm Felipe from Robots5. I would like to show you an example of inertia matching by choosing the gear ratio on a mechanical system. The plant we'll be working with consists of a motor and a load, similar to this diagram. Our goal is to choose the gear ratio to maximize the angular acceleration of the load for a given motor torque. To get the optimum gear ratio for this system, we'll be using the inertia matching formula, where J load is the moment of inertia of the load and J motor is the moment of inertia of the motor. The inertia matching formula is very popular, but it might not be too obvious how to derive it. So I'll do a detailed walkthrough at the end of the video using Maple. For this experiment, we'll be using our EMB modules. To get more flexibility with the gear ratio, we'll add a bearing block with two gear pairs, N1 and N2. In red, we have a motor, in green, a bearing block, in blue, an encoder, and in yellow, the inertia wheel. To use the formula mentioned earlier, we only need the moment of inertia of the load and motor. Given that the wheel inertia is much higher than encoder and bearing, we will neglect them for this calculation. Running the numbers, we get an optimum gear ratio of about 4.3. Now let's look at how to interface with the plant. We're using one of our DACs for data acquisition and real-time control. The encoder is fed into the DAC. An amplifier in current control mode powers the motor. A host computer is used for programming and interfacing with the DAC, and we also have an e-stop for safety. We are using pysimCoder and NuttX for controls and auto-generation of real-time control code that is deployed to the target. All the data collected is available for download. We'll be running 10 different gear ratio configurations, varying from 0.17 to 9.6. Based on our calculation, we expect configurations 7 and 8 to outperform the rest, as it's closer to the optimum gear ratio from inertia matching. Here we have 3 runs that illustrate the difference in performance. To evaluate the angular acceleration, we look at the slope of angular velocity for each run. The higher the slope, the higher the acceleration. These results match our calculations, with 4.0 and 4.5 yielding the highest acceleration. Now let's derive the inertia matching equation. For our case, it really is finding the optimum gear ratio equation. You might be asked to do this during an exam, design review, or technical interview. I'll be using Maple here because it can easily handle symbolic mathematics. We start with the equation of motion with everything reflected to the load shaft. The angular acceleration of the load shaft becomes this equation. Now we take the derivative with respect to n and set that equal to 0. We get the following equation. Now we solve this equation for n. We get 2 solutions. We'll choose the positive one. We have a negative with a negative. This will yield a positive. Now we have an assumption where T1 is small when reflected to the motor shaft. So we'll set it equal to 0. And we get the following equation. We can do a symbolic simplification to get the familiar equation. For more information, please visit our website. Thank you.